Hello everyone, welcome back to the Network Fixer. Today's video is going to be very important and also future focused session for anyone working in networking, security or information technology. Let me start with a simple question. Have you ever faced a network outage where everything looked normal but users were still complaining? Have you ever seen a security attack that completely bypassed your firewall rules? Have you ever spent hours troubleshooting an issue only to realize it could have been prevented? If your answer is yes, then this video is for you. Today, we are going to talk about machine learning in networking, security, and IT. Not as a buzzword, but as a real technology already running inside the tools you use every day. I will explain everything in simple language, without heavy mathematics, and with real-world examples from firewalls, Wi-Fi, SOC tools, and enterprise networks. By the end of this video, you will clearly understand what machine learning really is, how it works in networking, how it improves cybersecurity, why every network and security engineer must understand it, and how it will impact your IT career. So let's begin. Machine learning, often called ML, is a branch of artificial intelligence. In traditional IT systems, we write explicit rules. For example, if CPU usage is above 80%, raise an alert. If traffic matches this signature, block it. If a link goes down, switch to backup. These systems only work based on rules written by humans. Machine learning works differently. Machine learning allows systems to learn from data and identify patterns automatically without being explicitly programmed for every situation. Instead of telling the system what to look for, we give it data and it figures out what is normal and what is abnormal. In simple terms, machine learning answers this question: what usually happens in my network and what looks unusual? Types of machine learning. There are three main types of machine learning used in IT. First is supervised learning. In supervised learning, the system is trained using labeled data. For example, the traffic is malicious, the traffic is normal, this email is spam, this email is not spam. The system learns from past examples and applies that knowledge to future data. In networking and security, supervised learning is commonly used in firewalls, antivirus systems, and intrusion prevention systems. The second type is unsupervised learning. In unsupervised learning, there are no labels. The system simply looks at traffic, logs, and behavior and tries to find patterns and anomalies. This is extremely useful in networking. For example, if your network normally sees 2 GB of traffic at midnight and suddenly it sees 20 GB, the system flags it as suspicious, even if it has never seen that attack before. The third type is reinforcement learning. Here, the system learns by trial and error. It takes an action, observes the result, and adjusts the behavior. In networking, reinforcement learning is used in dynamic routing optimization, traffic path selection, wireless performance tuning. Let's now talk about how machine learning is actually used in real networks. Machine learning in network monitoring. Traditional network monitoring relies on thresholds. For example, CPU above 80%, memory above 70%, interface errors above a fixed number. The problem with this approach is that it creates too many false alerts, alert fatigue, no real root cause analysis. Machine learning changes this completely. ML-based monitoring systems learn what is normal behavior for each device, interface, application, and time of the day. Instead of asking, is CPU high, the system asks, is the CPU usage abnormal for this device at this time? This is a huge improvement. For example, a core switch running at 85% CPU during backup hours may be normal. The same CPU usage during business hours may indicate a problem. Machine learning understands this difference automatically. Machine learning in wireless networks. If we consider wireless networks, they are one of the best examples of ML in action. Wi-Fi performance depends on number of clients, interference, signal strength, roaming behavior. Manually tuning Wi-Fi is almost impossible. Machine learning based wireless systems continuously analyze client experience, packet loss, latency, roaming failures. They automatically change channels, they adjust transmit power, they optimize roaming. This is why platforms like Juniper Mist and Cisco DNS Center are becoming so popular. They don't just show problems, they fix them automatically. Machine learning in traffic engineering and WAN. In WAN and SD-WAN environments, machine learning helps select the best path in real time. Instead of static routing decisions, machine learning analyzes latency, jitter, packet loss, historical performance, then it dynamically chooses the best path for each application. For example, voice traffic goes through the lowest latency link, backup traffic goes through the cheapest link. This improves performance without manual intervention. Now let's move to security, where machine learning is absolutely critical. Why traditional security is not enough? Traditional security relies on signatures and rules. The problem is attackers constantly change techniques. Zero-day attacks have no signatures. Encrypted traffic hides malicious payloads. Machine learning solves this by focusing on behavior, not just signatures. Machine learning in firewalls and IDS or IPS. The modern firewalls use machine learning to analyze traffic patterns, session behavior, application usage. They can detect command and control traffic, lateral movement, data exfiltration, even if the attack has never been seen before. This is why next generation firewalls from vendors like Palo Alto and Fortigate are heavily machine learning driven. Machine learning in endpoint security. Endpoint detection and response or EDR uses machine learning extensively. Instead of scanning files only, machine learning monitors process behavior, memory usage, file system changes. If a system suddenly starts encrypting thousands of files, machine learning identifies it as a ransomware and stops it immediately. Machine learning in SIEM and SOC. SIEM tools collect massive amounts of logs. Humans cannot analyze this volume of data. ML helps by correlating events, reducing false positives, identifying insider threats. This allows SOC teams to focus on real incidents, not noise. Let's look at some real-world scenarios. First, network failure prediction. Machine learning analyzes hardware logs and predicts switch or disk failures before they happen. Second is with the ransomware prevention. Machine learning detects abnormal encryption behavior and isolates the system automatically. The next one is DDoS detection. Machine learning detects unusual traffic spikes and triggers automated mitigation. Many people fear that machine learning will replace network engineers. This is not true. Machine learning will replace manual and repetitive tasks, not skilled professionals. The future belongs to engineers who understand networking fundamentals, who can interpret machine learning insights, who can design intelligent networks. Learning basic Python, log analysis, and cloud networking is more than enough to stay relevant. The future will include self-healing networks, autonomous SOCs, zero-touch provisioning, predictive security. Networks will move from reactive to autonomous. To conclude, machine learning is not optional anymore. It is already embedded in modern networking and security tools. Understanding it is no longer a luxury, it's a career requirement. If you enjoyed this deep dive session, like the video, share it, and subscribe to the Network Fixer. Let me know in the comments if you want hands-on demos, lab setups, or real troubleshooting cases using machine learning tools. Thank you for watching, and I will see you in the next video. Until then, take care of yourself and have a great day. Bye bye.